Example 3 is an AP exam question from 2015, and it's a calculator question. And it says that Johanna jogs along a straight path, and the time is between 0 and 40. In this case, it looks like it's measured in minutes. That's Johanna's velocity is given by the differentiable function v, where v of t or values of v of t are given in a table. So this is a velocity function, so it's a rate function again, and it's measured in meters per minute. And since it's differentiable, we do know that this is smooth and continuous. So use the data to estimate the value of v prime at 16. So in this case here, we have to estimate because we can't get the exact value of this because we're not able to differentiate this function. We don't know what it is. So we're going to use an estimate. And to do that, what we want to do is take the average slope between points that 16 lies in between. So t equals 16 is in between 12 and 20, which I've highlighted in green. So we're going to take the slope value of that between those 2 points and say that's the estimate of the derivative at 16. So v prime of 16 is approximately equal to v at 20 minus v at 12 over the time interval 20 minus 12. And so this works out to be, we have 240, that's in meters per minute, and minus 200 over, looks like 8. And so that's going to be 40 divided by 8. And that's going to be in meters. The units of this are going to be in meters. So it's going to be 5 meters per minute, or per minute squared. So this would be represent the acceleration that in that time period. Part B says, using correct units, explain the meaning of the definite integral from 0 to 40 of the absolute value of v dt. So when we take the area under the v graph, we're going to get the displacement. Normally, in this case, the displacement between 0 and 40. However, the absolute value means that we're going to take all the negative displacement and calculate it as positive. And that means that we're getting distance. Okay, so in the context of this problem, the absolute value that makes this the integral equal distance. It says approximate the value of this integral using a right-Riemann sum with 4 subintervals. So I've just kind of sketched the graph of these coordinates, just kind of estimated some coordinates here, and drawn in right rectangles, right Riemann sums. And so what we're going to do then is we're going to calculate these different areas. So in the first area, we have a right Riemann sum. The height is 200, the width is 12, so we're going to end up with 2,400 meters. Okay. Between 12 and 20 seconds, that's 8 seconds. The height is 240 meters per minute. Sorry, this is 8 minutes, 240 meters per minute. So we get 240 times 8. And that's going to give me 1920 meters. For the next interval, it's going to have a height of negative 220, a width of 4 minutes. So this works out to be, and I'm just going to do it in a different color. This is going to be negative 880 meters. However, we're going to convert that into a positive value because although it's moving in the wrong direction, it does move a distance of 880 meters. And then lastly, we're going to have a height of 150. That's the right edge of that Riemann sum of that rectangle. We have a width of 16. And so we end up with an area of 2,400 meters again. So approximating this value, taking the absolute value into consideration, we're just going to add up these. This is going to represent the distance. So this is this distance traveled. That's going to be equal to the 4 Riemann sums, the 4 Riemann rectangles. So this is where we have to convert this into positive. This becomes positive 880 meters, and then plus 2,400 meters. The total distance traveled works out to be 7,600 meters when I add that all up. Okay, and this represents the distance, not the displacement. In part C, it says Bob, who's riding his bicycle along the same path for 0 to 10 seconds, Bob's velocity is modeled by the b of t function, which is a cubic polynomial function, t cubed minus 6t squared plus 300. We want to find Bob's acceleration. Okay, so we know that b prime, do this in a different color, we know that b prime of t is going to be the acceleration of Bob. Okay, so that's what we're looking for. We're looking for the acceleration, and then we can plug in the time equals 5. So differentiating this expression, we get 3t squared minus 12t. Okay, so there's our acceleration function. We can then calculate the b prime at 5, which is same as acceleration of Bob at 5, and that works out to be 3 times 25 minus 12 times 5, which is 60. So we get 15, and this is going to be meters per minute or per minute squared. Lastly, it says, based on the model of b of t, find Bob's average velocity. Okay, so b is the velocity, so we want to find the average value of b. And we're going to use the average value formula. So to find the average value of f of x, we just find the area under the f of x and divide it by the interval. So in this case here, we're going to find the average value of his speed, b of t. So his average velocity. So the average velocity is going to be calculated from the area under the curve, which is a total distance. So that total distance traveled from 0 to 10, and that's under the b of t function. So that's the total distance traveled, or the total displacement, and then we're going to divide it by the time interval. So we divide it by 10 seconds. So the total displacement divided by 10 seconds is going to give us 10 minutes is going to give us the average velocity, which is in meters per minute. So if we keep track of the units, it makes sense. So then this works out to be 1 over 10. The area that is going to be the antiderivative of this, so we're going to anti-differentiate this expression. So anti-differentiating the original expression, we're going to get t to the power 4 over 4 minus 6t cubed over 3 plus 300t, and we're going to evaluate this integral from 0 to 10. So the displacement from 0 to 10 will give us the total distance traveled. So we end up with the total distance is going to be, when I plug in the 10, okay, and maybe I'll just simplify this out first. So this is going to be equal to t4 over 4 minus, this is going to be 2t cubed plus 300t, and we're going to evaluate this integral from 0 to 10 and divide it by 10 minutes. Okay, so working out this integral, in the numerator, we're going to end up with 10,000 divided by 4. So t to the power 10 divided by 4 is 2,500 minus t cubed is going to be 1,000. So 2 times 1,000 is minus 2,000 plus 300 times 10 is going to give me 3,000. So this is going to represent the total distance traveled. So it looks like he goes a distance of 3,500 meters, or 3,500 meters when I work that all out. So that's going to be 3,500. That's going to be meters, and that's all over 10, which is 10 minutes, which gives us the average velocity as 350 meters per minute.